Hello, third years. Last class we have stopped at Coulomb's inverse square law. Its vector form and Coulomb's inverse square law in terms of position vectors. Today we are going to see what electric field is. Electric field due to a monopole and multiple charges. Let us first try to understand what electric field is. Let us say I have a charge Q, a point charge Q, and at a distance r, I have a point P. Now, at the point P, let me place another charge Q naught. The moment I place a charge Q naught at P, this point charge Q naught is experiencing a force. Supposing I remove this charge from the point P, nothing is there at P. Now, again I am placing a charge Q naught at P. This charge again experiences a force. The question now is, when you place a charge Q naught, experiences a force. When it is taken off from the point P, there is nothing there. What does it mean? It means, or it signifies, that in the space surrounding this charge, the point charge Q is producing a field. That field, I call it as electric field. And therefore, when a charge Q naught is placed at the point P, it is experiencing an electric force. What does field means? Field is a general term which is used to signify a physical quantity which gets distributed. So this gets distributed around the charge capital Q, and therefore I call it as an electric field. That charge which is producing a field, I call it as source charge. I call this as source charge. That charge, therefore Q, is source charge for me. This charge which is used to test whether a field exists or not, I call that as test charge. I call it as test charge. From this, I would like to define electric field intensity or electric field strength. Electric field strength or intensity. How do I define it? Electric field intensity at a point in an electrostatic field is defined as force experienced when a unit positive charge is placed at that point. I hope you have understood. If not, I will make it clear. Let me rub this off. I have a charge Q and a point P is there, the distance R. I want to find out what is the electric field strength at this point P. All that I need to do is to place a unit positive charge. When a unit positive charge is placed at P, whatever force it experiences there will give you the strength of electric field intensity or strength at that point. Therefore, I will write this as E is equal to F upon plus 1. Instead of unit charge, you place a charge Q naught and it experiences a force F. Then I will write E is equal to F by Q naught. Electric field is a vector. Therefore, I will write the expression as E is equal to F vector upon Q naught. I repeat once again. Electric field intensity at a point in an electrostatic field is defined as force experienced by a unit positive charge placed at that point. This is the equation. This is not H, this is plus. On the other hand, you place a charge Q naught, test charge. It experiences a force F. Then electric field intensity, I will write it as E is equal to F vector upon Q naught. From here, I am interested in deriving an expression for electric field at a point due to a point charge. Electric field due to a point charge. Let me take this point as O, where a charge Q is there. At a distance R, there is a point P. Electric field to a positive charge will be pointing outwards. Situation is very simple. Problem is very simple. At some point O in free space is placed a positive charge plus Q. At a distance R from this point charge Q is a point P. I want to find out what is the strength of electric field intensity at that point. From the definition, I know it is E is equal to F by Q naught. Therefore, in order to determine the electric field strength at point P, let me place a test charge Q naught. If I place a test charge Q naught at P, from Coulomb's inverse square law, I will be able to find out what is the Coulombic force that exists between these two charges. Am I right? Therefore, from Coulomb's law, the force between charges. Okay, I write F is equal to 1 by 4 pi epsilon naught Q. The test charge is Q naught, distance is R square. Let us make it express that in a vector form. Therefore, I put a vector multiply by a unit vector. As simple as that. Now, from the definition of electric field intensity, I write electric field E is F vector upon Q naught. Therefore, I write 1 by 4 pi epsilon naught Q naught upon R squared into Q naught upon R unit vector. Therefore, I get this as E vector is equal to Q by 4 pi epsilon naught r squared into r unit vector. This is the expression for electric field intensity due to a point charge at a point P. This is not new to you. In your +1, +2, you have studied this. Now, if there are multiple charges, what happens? That's what we need to see now. For that, let me draw a diagram. I will rub this off. Electric field due to a system of charges. If you draw a diagram for that. Let us suppose I have a charge Q1 here, Q2 here, Q3 here, and a charge Q4 here. Let this be point P. Okay? Now, due to this charge, electric field is E1. Let me mark it as E1 vector. Due to this charge, Q2, electric field is E2 vector. Due to this charge, Q3, electric field be E3 vector. Due to this charge, Q4, electric field be E4 vector. Is that okay to you? Now let me so it becomes easy for me to join. This is E3. Okay. This is E1 vector. This is Q1. This is R1P, R2P unit vector, R3P unit vector, R4P unit vector. Clear, sir? Now, let me run this part. Proceed. electric field E1 at R. See, this is at P due to Q1. This is a distance R1P. Therefore, I will write it as E1 vector is equal to 1 by 4 pi epsilon naught Q1 R1P squared into R1P unit vector. This equation we are familiar. Just now we have discussed that electric field due to a point charge. I have written it here. Similarly, E2 I will write it as 1 by 4 pi epsilon naught Q2 R2P squared into R2P unit vector. Any number of charges, n charges we have. Similarly, you can write n such equations. Now, we are going to use from the principle of superposition. Already I have told you, from the principle of superposition, we can find out the resultant electric field. Resultant electric field at this point P due to all the charges is the vector sum of electric fields at point P due to individual charges. Okay. Therefore, E vector at R, if I say position vector is R, okay, E1 vector R vector plus E2 vector R vector plus dot 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 En vector R vector. This is N. Okay. Therefore, I will write this as 1 by 4 pi epsilon naught Q1 R1P squared into R1P unit vector plus 1 by 4 pi epsilon naught Q2 R2P squared R2P unit vector dot 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 for the nth charge 1 by 4 pi epsilon naught Qn RnP squared into RnP unit vector. Instead of writing that big an equation, we can simplify this in this fashion. I will write E vector R vector is equal to 1 by 4 pi epsilon naught sigma I is equal to 1 to n Qi upon Rip squared into Rip unit vector. This gives you the total electric field due to a system of charges at a point P. So you can determine the electric field due to multiple charges in this fashion. So we have seen how to determine electric field due to a single charge due to multiple charges. From here, we proceed to see what an electric dipole is. All these things you have studied in +2. Shall I rub this off? Now, before I go into the next topic, the